Hello everybody. Today we'll talk about KNN algorithms, K nearest neighbors. Uh, Actually, the first algorithm is logistic regression. The same data set, it is that same data set we will use the same data set at KNN, and we used logistic regression, and the we look performance about the model. Accuracy score is 0.94, and we wonder the how accuracy score is KNN algorithms. Firstly, I just want to speak about KNN just shortly. How is it work? For example, we don't know this value, which class, A or B. We choose a number and neighbors. For example, 3. Uh, we we measure the how far from this value. For example, this B1, this A 2.24, and this A 2 far from this value, unknown value. The nearest three class are that A, and B. We can say that this is A because 2A and 1B. The nearest three class, 2A and 1B. So we can say that this unknown value is class of A. Uh, it's it's basically KNN algorithm works that. Let's start to coding, and now importing the libraries. We can start import from import pandas. Actually, I just want to talk about datasets. What is that? I talked about the logistic regression videos, but I want to talk about now. This is a cancer. This is a about cancer dataset. This R is features, and this is the target columns class, and bad or good cancer tumor is malignant or the nuts. This is the column sample code number. We don't use that because like a patient's number, so we don't use this uh, column, and we can start to coding. Import pandas as pd, and now we can I didn't add this is I am adding importing libraries and importing the dataset, importing the dataset, and now importing dataset pd read csv. We use this function, and data.csv, and I like the copy this dataset dot copy, and we can look this dataset just 3 index. Yes, we don't use this column, and this is our target column. And now x is df ilog all indexes, and 1 2 minus 1. What's the meaning of the before the comma? This is the meaning of all index, and after the comma, this is meaning of to start one column. One column is column thickness. We don't use this column, sample code number. Start one column, column thickness, and the last column, two last column, but without last column. We don't use class for features. That's values. And y is the our target df.ilog, the all index, and just the last column. That's yes, that's right. And we can split the train and test sets from scikit-learn dot model selection import train test splits x train x test y train y test s, and we use this function train test splits at x and y, and test size. Test size is the same all. We use the same size all the algorithms I will show, and random state the same. What's the same? Random state 0 and test size is 0.25. Logistic regression we used that, and test size is the same and random state is the same. And that's right, very good. And feature scaling. Feature scaling is the support our model, improve our model. So we use the feature scaling from scikit-learn, from learn pre-processing. We use pre-processing import standard scaler. That's right, and we create a object and standard scaler. We don't use the parameters, and we use just our features, xtrain and xtest. We scale just our train sets and test sets. Xtrain equals object that's fit transform. What's which we use this inside xtrain. That's right. Xtest equals says dot fit transform xtest. Very good. And now we can do our model, neighbors model. Let's start from scikit-learn dot neighbors, import k neighbors classifier. Very good. Just a minute. Very good. And now we can add an object knn classifier equals kn neighbors classifier, and will use an parameter. What's the parameter? I said that neighbors parameter. For example, we choose three neighbors, the nearest three neighbors. and n neighbors equals 5. We can say 5. The default value, I know 5. Let's look that. Yeah, n neighbors 5. Default value is that, and we use 5. Very good. And we can do our model knn dot classifier dot fit, which what will use that xtrain dot ytrain, and an error normal name scikit-learn neighbors. Actually, and sorry, and copy this, copy and paste. Very good. And we do our model, and now we can predict our test set. Ypred equals our object knn classifier dot predict x test, and the model is predict our test sets, and we can look this model performance. We use confusion metrics and accuracy score from scikit-learn dot metrics import confusion metrics and accuracy score. Yes, and print accuracy score is firstly we use the real target, the real value, y test, and our predict values y pred. Yes, that's right. And this copy paste confusion matrix, copy and paste. Yes, very good. And just firstly look I want to look logistic regression performance accuracy score and 0.94, and now KNN algorithm, how accuracy score. Let's look 0.94, the same. I have and confusion, yes, and confusion, that's right. Yes, the same accuracy score. Interesting. Very good. And let's look that. This is the logistic regression 0.947 and 0.947, the same. That's very good and interesting. And we learn how to do KNN and how does it work, and we will look this SVM support vector machine and random forest decision tree algorithms, and yes, that's right. Have a good day. Until then, have a good day.